Welcome back to my channel again. Today we're going to talk something about quantum fields, not so deep but slightly about it, because it's a point of concern here as we try to dive deep into atomic and subatomic stages. Deep down we have the quarks, deep down we have the fields. So now first, before we go there, okay, let's start with that. What are the quantum fields actually? The physicists say at the deepest level everything is made up of mysterious entities. They are fluid-like substances called quantum fields. These invisible fields sometimes act like particles and sometimes like waves. They can interact with one another, and they can even sometimes flow right through us. So that's what we call quantum fields. And when you go up, now the question is, now we have these mysterious entities which you call fluid. They are fluid-like substances. What are really they? What are they? What are these things? So we're gonna see somewhere where I put some notes about it, and probably they say that the universe, those fields, their postulates will say maybe the electrons, because you know the electrons is part of, we have the electrons, we have the neutrons, we have the protons, right? And if you go to the Big Bang, when this energy started to explode, and when matter formed or atoms formed, then electrons was part of that. But here we are told that the electrons are now acting as a fluid which fills the universe. So the universe, our universe, is filled by electrons. And the electrons are just energy actually in a small state, like an integer of a quantity of energy. Okay, and when you talk of energy anyway, I like to take you to another part. When you talk about energy, what do we actually mean? And I'm trying to get you that, guys. That's all. Sorry, I have to do this. So there is a definition of the relation between energy and matter. Of course, everything is made out of matter. Matter is something, you know what's matter. If you follow me, you know already what that is. Now, the small amount of mass, M, mass is something that has weight and can occupy space, can be interchangeable with enormous amount of energy. All right, and the equation is E is equal to mc squared. Is a classic equation. So we are talking of electron field filling the entire universe. Now I also wonder sometimes, like when I wrap my hair, when I wrap my hair, you hear sparks, static electricity coming out of it. Now I wonder what really is happening. How is my hair getting electric charges? Have you ever wondered? Have you ever tried? You tried. So we have electron field which fills the universe. Now waves of this field is tied to a little band of energy. Now it's just a description, and they say these waves is a fluid, and the fluid is waves, and waves is particles, and these particles are electrons. And these things are what we call mysterious things, and they are waves, they are fields. So what if you are to take all the fields out? So what will be there is a vacuum, and we'll have something called quantum fluctuation of vacuum fluctuation. Now a vacuum also has energy, and there where we have visual particles come into existence, which exist for a short time, they annihilate each other. This is quite strange. So actually we going to the state of nothing. That's what vacuum means, is nothing. Now nothing has virtual particles. So, and virtual particles come into existence and disappear as quickly as they come. So, a little band of energy, by rules of quantum mechanics, we call particles the electrons, or electrons. You have electron in your body, and now in microscopic scale, the world has these kind of things according to quantum mechanics. So guys, we are trying to examine this deepest level, what really lies there. Energy is not continuous according to quantum mechanics. It comes in form of discrete particles. Discrete means small quantities or lump-like. There is also something called Faraday's, which says that energy is continuous, and now we have to combine these two. Now quantum particle is what we call photons. So I was just describing to you the state of nothing, the empty space, and there we also have something going on. In the emptiness, the vacuum fluctuates. Isn't that strange? If you take everything out, there's still something there fluctuating. So this is quite strange. What is it? So these fields, these things the thing that fluctuates, that's why I say that the things that fluctuate will be considered to be these fields, because now there's nothing, there's a vacuum, but still fields are there. So these fields are the ones that are actually fluctuating. That's according to quantum mechanics. And of course we have the uncertainty principles, which says that there's Heisenberg, who says there's a momentum and there's a position of an electron, and you can't fix both. One has to be moving. So when you take out all this stuff, still you find that the field has to move. So we have the field fluctuating. Now we call these quantum vacuum fluctuations, and this is what we call nothing. Nothingness looks like this. Okay. Well, guys, I'm trying to give you the notes that I've really researched on. So these quantum fluctuations are there in pure vacuum. They can be measured. So isn't it a mystery? Even try to understand that, or something like a Big Bang. How did the Big Bang start? We did all these kind of strange things. We have Schrodinger also, Higgs boson, which we touch on next, Planck scales. So let me talk something about electrons being wave packages, which I've told you, entities, wave particle duality in quantum mechanics. So it's the same thing. So it's not possible to know the position of an electron at the same time its momentum. The closer you are knowing the position, the more difficult it is to know the momentum and vice versa. This is about quantum fluctuation. Today I'm going to give you deep definitions of these terms. Now, in this thing called quantum mechanics, it doesn't apply to something that moves at the speed of light, right? There we have something called special relativity, and what is it? In special relativity is how speed affects mass, time and space. That's what we call special relativity. So quantum mechanics does not apply there. Quanta. This word must be confusing you, but I've told you repeatedly what quanta is the tiniest bit of a phenomena, it's quantum mechanics. So in the theory of relativity, it takes over when things are moving at the speed of light. Quantum mechanics does not work there. Now, in special relativity, we can define it as a relation between energy and matter. A small amount of mass, which I've told you can be interchangeable. That's what I told you before. Right? Yeah, man. So here they say that the quantum mechanics combine with special relativity and give rise to quantum field theory. Okay, so when I talk of the quantum field theory, I'm just referring to quantum mechanics and special relativity, which I've told you what the special relativity is. It's a relationship between space and time. Now, an electron excitation in the background quantum field, I and everything are excitational quantum fields. Just defining what is in these fields. We are all excitation of this field according to this theory. Vibrations. We come to existence and we dissipate. We go back to the fields from where everything starts. How do you find this? So when you talk of an atom, let's start from a molecule. A molecule is formed from atoms, and then what's in an atom. You have electron, proton, neutron, and nucleus, and then how these things interact. Even in the primordial time when these things started to form, 380,000 years after the Big Bang, when matter started to cool down and atoms started to form, these things came into existence. Then electrons came to be, protons came to be, neutrons, and of course photons was interacting with these particles, so there was no light. At some stage the photons were let free and they formed what we call microwave, cosmic microwave background radiations. What is radiation, by the way? Radiation is the energy that comes out of something, and this became the light. That's when light first showed. Okay, you could imagine the universe without light if you were there. So what will you see? Anyway, we all formed from this, so we came to exist at our own time. Yeah, and there's quite a lot really talk about this topic, but today I'm trying to give you general things about this subject, quantum fields, which is the real building blocks of the universe said to be. Okay. So, if you follow me, I'll detail on some of these things: the quarks, antiquarks, the mesons, muons, gluons, Higgs boson. Higgs boson, which was recently discovered, is a particle that gives weight, gives mass to other things, and that's why they call it God particle. Can you imagine something to exist without mass? Without this Higgs, the name Higgs is named after the discoverer, but it's a particle. It could be a field actually, rather than particle. All these things are just theories, and observations. There's no concrete. Like now, what's happening right now. The theory of Big Bang is being debunked due to this I call James Webb telescope. Is it James Webb? Yeah, which is going deeper and further and discovering very gigantic things which ought not to exist. Beyond the Big Bang, there's still some stuff existing there, and very gigantic objects. So that's a limitation of our observations and what we understand to be the reality. Okay guys, I don't think I have much to tell you today. It's just a general topic I'm giving you based on these things, like what is a molecule, what's the atom, how these atoms were formed, and the electron, proton, neutrons, right? I've already told you in the previous video about this. So guys, I think I'll end it here for today, and stay tuned as we bring in more and more topics. And yeah, stay tuned. Please like, share and subscribe to my channel, and see you again. Bye.